Okay, two quick examples with signed areas. So in this case, what we have is we're trying to find the definite integral of this function f of x equals -2, nice constant function, on the interval from 1 to 4. So if I wanted to write this with a definite integral, I'd have my integral sign, my bounds of integration, 1 and 4, and then our function gets plugged in here. Now, I'm going to use dx as we are looking at x values of 1 and 4. All right, so to calculate this, we can actually do it as an area. You'll see that the graph is over on the left-hand side, with -2 being this constant function going across here. Because it's below the x-axis, we draw between 1 and 4, we draw the shaded region is going to be up to the x-axis. All right, so to calculate what's the area of that shaded region, well, we can use length times width, right? Because it's a rectangle, so length times width. And you can treat whichever one you'd like as the length, whichever one you want as the width. It doesn't really matter. I would say it's 4, it's 3 going across. 4 minus 1 makes 3. And then it's 2 on the sides. So the area is going to be 2 times 3. But when we give our answer here, we have to make it a -6. All right, it's going to be negative because the area that we just calculated is below the x-axis. It would be positive if it had been above the x-axis. All right, one more on this video. Looking at, in 1980, we're given an initial population of ducks nesting in a lake, and the rate of population change in ducks per year is given in our graph. That it looks like it's decreasing by 200 per year. First thing we're going to do is write a definite integral for our situation. We want to represent this total change in the duck population from 1980, so that's our lower bound, to our upper bound, 1990, and estimate the population in 1990. All right, so we don't really have a name for our function here. I'm just going to call it f of x. All right, so you could also equivalently gone ahead and said, well, that's 1980 to 1990. We can say that's -200 because it's a constant function. Dx means the same thing. All right, so to calculate that area, it's going to be 10 across, 200 on the side, so it's going to be 2,000 total for our area. All right, so this equals -2,000 because that was below the x-axis, meaning that it's going to be negative. All right, and then what about estimating the population in 1990? So the population in 1990 will be whatever the starting population was, the 1980 population, plus whatever the change in population is. All right, so the 1980 population, we are told at the beginning there was 12,000 ducks. But we just calculated that integral and figured out the integral was -2,000. So that means that 2,000 less ducks are there in between 1980 and 1990. So this would give us an estimation of 10,000 ducks in 1990. All right, hope this helps out as you're working on signed areas. Remember, below the x-axis, it's going to be negative area. Above the x-axis would be positive.